Hello everyone, my name is Leah Kunke, and today we'll be discussing light, energy, and wavelengths. Let's begin with light. The speed of light is 3.00 times 10 to the 8th meters per second, and is a constant value, but light's wavelength, energy, frequency, and amplitude are all variables. Wavelength is the distance between two crests of two waves, and is symbolized with the symbol lambda. Frequency is the number of waves or crests that pass through a stationary point at a given period of time. Amplitude is the wave's vertical height of the crest. Now let's see how all these variables relate to the electromagnetic spectrum. As we go down the electromagnetic spectrum, the wavelength increases. The wavelength of light determines whether it's red, blue, gamma rays, or radio waves. As we go up the electromagnetic spectrum, the frequency increases, as well as energy. The energy of light is directly proportional to frequency and indirectly proportional to wavelength. The amplitude of the light determines its brightness. A low amplitude is dim, while a high amplitude is bright. The way light is emitted can best be explained through particle view. Let's take helium. Helium has 2 electrons, both in the s orbital. When helium absorbs energy, it becomes in an excited state, in which an electron jumps into a higher energy level. When this electron falls back down into the s orbital in its ground state, it emits a photon of light. The energy of this photon determines its place on the electromagnetic spectrum. High energy photons might be gamma rays, and low energy photons might be visible light like blue or red. The amount of photons emitted determines the amplitude or strength of the light emitted. A large amount of helium atoms would emit a stronger light than a smaller amount of helium atoms. Wavelength, energy, and frequency are all related to each other in these two equations. E equals h nu and C equals lambda nu. E is equal to energy, h is equal to Planck's constant, which is 6.626 times 10 to the negative 34th joules per second. Lambda is equal to wavelength. Nu is equal to frequency. And C, as we mentioned before at the beginning of the video, is the speed of light, which is 3.00 times 10 to the 8th meters per second. Now let's take a look at a practice problem. Calculate the wavelength in nanometers of the red light emitted by a barcode scanner that has a frequency of 4.62 times 10 to the 14th second. To solve this problem, we would use the equation C is equal to lambda nu. To solve for wavelength, we would set the equation equal to lambda. Then we would plug in the known values, which is speed of light and frequency. We know speed of light is 3.00 times 10 to the 8th meters per second. And in the problem, we are given the frequency, which is 4.62 times 10 to the 14th seconds. The seconds cancel out, and after calculations, we are given the answer 6.49 times 10 to the negative 7th meters. Now, pay attention to units here because it asks for the answer in nanometers. The conversion from nanometers to meters is 1 nanometer to 10 to the negative 9th meters. Using this conversion factor, we use simple stoichiometry to convert 6.49 times 10 to the negative 7th meters into nanometers. We cancel out the meters, and we're left with 649 nanometers, which is our answer. Thank you for watching.